Hey everyone, this is our second Math 70 video. I decided that I'm going to add a little bit more video lecture to section 1.1, so we'll call this part 2, and these are all about word questions. Word questions are going to come back again and again throughout the whole course, so I think it's actually pretty useful to have a separate video. So in the previous video, I did symbolic equations, things like 2x plus 1 equals 11. That was an example of a symbolic equation, a symbolic mathematical idea. And symbolic equations allow us to use the tools of algebra pretty easily. But when you're actually out there in the world doing the math, you don't often come across something that looks like the symbols. Instead, what we're going to come across is situations that we encounter in a verbal way. So I'm going to remind you yet again of my 4 representations of mathematical ideas. I think I call this pictures or visual, numbers, which often take the form of tables. There are 4 main representations of mathematical ideas, and they're all connected. And word questions start here in the middle. So something like, let's see, I'm going to grab one from the homework. Jenny is twice as old as Roger. If Roger is 19, how old is Jenny? Now, it's quite possible that you don't need to convert this into a symbolic equation in order to solve it. You might say, well, Roger is 19, Jenny is twice as old, so Jenny is 2 times 19, and your calculator or your brain can tell you that's 38. So not every word question has to be converted to symbolic numbers or pictures, but it's good practice because the more challenging word questions definitely can help to convert them. So I would say something like, let X be Jenny's age. And then you know that, and let Roger's age be 19. So then you would know that X is 2 times 19. Jenny's age is twice Roger's age. So X equals 38. One of the challenges with converting verbal to symbols is getting everything in the right place. This is actually something I struggle with. Often my first instinct would to be write something like 2x equals 19 because I know it's a double, right? Twice as old, but I'm not sure where the 2 should go. And so that's something to keep in mind. Reading the sentence back to yourself, X equals 2 times 19. Jenny's age is 2 times Roger's age. That sentence makes sense. The one on the right would say 2 times Jenny's age is Roger's age. But that would tell me that Jenny's younger, so that one doesn't work. So this is a very basic example. Another example might be Cat has 38 more carrots than Blinken. I'm just making names up. And Blinken has 62 carrots. Oh, you couldn't see any of them. My apologies. Okay, Cap has 38 more carrots than Blinken. If Blinken has 32 carrots, how many does Cap have? Okay, our first step is let X be caps carrots and let Lincoln have 62 carrots. And then we would say, okay, so caps carrots X should be Blinken's carrots 62 plus 38 more, which our calculator could tell us is 100 carrots. Notice both of these started with the X by itself on one side, which honestly, if you're going to start with the word question, is usually how it ends up. And so math textbooks kind of have to write things in funny ways. So here's a question directly from your homework. This year, I graded 28 fewer exams than last year. If last year I graded 195 exams, how many did I grade this year? Maybe not how I would word this question, but either way, we're going to change this verbal representation into a symbolic representation. So X is going to be the number of exams this year. And 195 will be the number of exams last year. And so that means if I take this year's exams and I add 28 more, I'm going to get to last year's exams. This is saying, if I were to read this as a sentence, I would say the number of exams I graded this year plus 28 equals the number of exams I graded last year. And nobody talks like that. Nobody says what I have this year plus 28 more is what I had last year. People would always say, this year I graded 28 classes less than last year. But these are mathematically equivalent. And so the ability to go from these different symbolic equations, or to see how both of these symbolic equations match this verbal one, is an important skill that you're going to be working on during this class. Here's another one that involves multiplication or percentages. And this also comes from your homework. 25% of a number is 84. What is the number? Okay, so how I would do this, I would say let X be the number. And so 25% is 0.25. If you want to review your percents, you can search YouTube or something else for percent and decimal review. But 25% is 0.25. So I have my number X, and if I take 25% of it, so I multiply by 0.25, I'm going to get 84. 25% of my number is 84. Now, if I want to solve for X, I could grab my calculator and divide both sides by 0.25. Nothing wrong with that. And I get X equals, calculator will tell me that's 336, I think. All right, that wraps up this video. Lots of homework questions to practice this idea. Use your textbook to help you as well. And I'll see you for section 1.2.